Now you may.
Yes, yes. Okay, thank you. So suppose, please write that problem. Suppose electron in the hydrogen atom. Suppose electron in the hydrogen atom initially at state Ni equals to 300. So initially electron where? At 300. Now it is making transition from 300 to 299. It means final state is 299 by emitting photon. So suppose electron in the hydrogen atom initially at Ni equals to 300. Now it is making transition to final state. That state is 299, state number or principal quantum number is 299. So what will be the wavelength of emitted photon? That you have to calculate. So I am again repeating. Suppose electron in the hydrogen atom initially at Ni, where Ni is the principal quantum number, at 300. Now it is making transition to final state, that is 299. So that emitted wavelength, the wavelength you have to calculate for emitted photon. Can you calculate? So how will proceed? Anyone? So I think you wrote that problem. Now we'll proceed for solution. So how will proceed? So if you remember, the wavelength of emitted photon, that is lambda, then 1 by lambda equals to, for hydrogen atom, it will be simply R into 1 by NF square minus 1 by Ni square. Okay. So R is the Rydberg constant, NF is the final state principal quantum number, and Ni is the initial state principal quantum number. So from this equation, you can calculate that wavelength of emitted photon. Okay. So straightforward calculation. Now you can do it. So 1 by lambda is nothing but, please keep R as it is. Now it will be how much? Final NF is how much? That is given 299 square. Then you have initial state is 300 square. So basically, how much you will get? You will get R into, inside bracket, 300 square minus 299 square divided by, you will have 300 square, then you have 299 square. So that is nothing but 1 by lambda or wave number. But you have to calculate wavelength, right? So you have to inverse this equation. So if you inverse it, you'll basically get lambda is nothing but lambda will be how much? It will be simply 300 square into 299 square divided by R. R is how much? Anyone? R is how much? If you remember, I have written that R is Rydberg constant. Its value is 1.09 into 10 to the power 7 meter inverse. 1.09 into 10 to the power 7 meter inverse. Then you have another factor, that is 300 square minus 299 square. Okay. Now it is a simple calculation. If you do this calculation, you will basically get lambda equals to 1.22 meter. You can see that wavelength is very large, 1.22 meter. Did you get this question? Solution? Any doubt? Any doubt, Karthik?
No, sir.
Did you get? Okay. Next problem. Any people heard about muonic hydrogen? Anyone? So, shall I proceed? Did you finish this calculation?
Yes, sir.
Okay. Sorry. Now, write that second problem. Calculate the energy. Please write that second problem. Calculate the energy of first and second Lyman line. Calculate the energy for first and second Lyman line for muonic hydrogen. For muonic hydrogen. I'll write that word. So calculate the first and energy of first and second line of Lyman line of muonic hydrogen. Muonic hydrogen. Okay. Also calculate the energy of first Balmer line of same system. So again I am repeating, calculate the energy of first and second Lyman line of muonic hydrogen. Also calculate the energy of first line of Balmer line for same system. I mean system is again muonic hydrogen. Now you people might ask me or may ask me what is muonic hydrogen. It's an obvious question, right? Is not it? What
Yes,
is
sir.
muonic hydrogen? It's a valid question, right? Karthik, you know what is muonic hydrogen?
No, sir.
Okay. Anyone in the class? What is muonic hydrogen? So basically, if you see in hydrogen atom, you have proton at center, right? And electron is revolving around this, right? But in muonic hydrogen, what is basically that system? You will have proton at the nucleus, but that orbiting particle is no longer electron. Now it will be mu meson. Sorry, mu lepton. Okay. So inside nucleus you have proton and orbiting particle is muon. Okay, this is muon. Okay, this particle name is muon. Okay, so this is muonic hydrogen. This system is known as muonic hydrogen. Now, if you remember last class, for first and second line of Lyman means transition is happening from first line means for first line of Lyman means transition is happening from n equals to 2 to n equals to 1, and second line means n equals to 3 to n equals to 1, because this is all about your Lyman series, right? Final state should be n equals to 1. And for Balmer line, that first line means transition from n equals to 3 to n equals to 2. So energy difference of second and first state will give you energy of first Lyman line. Similarly, energy difference between n equals to 3 and n equals to 1 will provide you the energy of second Lyman line, and energy difference between n equals to 3 and n equals to 2 will provide you the energy of first Balmer line. Did you people get what I am saying? Did you people get what I am saying, or shall I repeat? Shall I repeat, or you people got? Please respond me so that I can understand. Did you people get what I am saying, or shall I repeat?
Yes, sir.
Did you got? Okay, sir. Okay, so you got this, right? So you have to calculate that energy difference. But I said that this system you don't know. So how you will proceed for energy calculation? Because you have ultimately you have to calculate the energy of this state, energy of this state, energy of this state. But you don't know. You know for hydrogen that is very simple from Bohr model. Then how will proceed? You have to proceed that equation I wrote for finite mass. That correction was En dash equals to how much? Mu by me, right? Mu by me into En. So for any system you can calculate the energy by using this formula. En dash equals to mu by me into En. So En is the energy of hydrogen atom. Okay, and this thing you can calculate. Just you have to know the reduced mass of this system. Again, you may ask me, what will be the mass of this muon? Because you don't know that mass of muon, then how will you proceed for calculation? Reduced mass. Ultimately, reduced mass means what? Then mass of this fellow into mass of this fellow divided by mass of this fellow plus mass of this fellow. Is not it? If you remember, reduced mass formula was mu equals to m1 m2 divided by m1 plus m2. Okay, here m1 m2 are mass of proton, mass of muon. So just you have to substitute a mp into m mu divided by mp plus m mu, right? But you don't know mass of muon. Then how will proceed? That's why I will provide you that mass. Also in the question they will provide you that mass, no problem. So mass of muon or mu lepton basically 207 times the rest mass of electron. And I'm sure you people know that mass of proton is how much? It is basically 1836 times the mass of electron. Is not it? So now you know that mass that will basically provide you in the question. The mass of mu particle is 207 times the mass of electron or rest mass of electron, and mass of proton is 1836 times the mass of electron. Now you can easily calculate that reduced mass, right? In terms of the mass of electron or rest mass of the electron. Anyone, can you please calculate it and tell me for muonic hydrogen system how much will be the reduced mass in terms of the mass of the or rest mass of the electron? So just you have to what you have to do? Please proceed. So what you have to do? You have to substitute this mass. So reduced mass is nothing but the mass of this fellow 207 times mass of electron into 1836 times the mass of electron or rest mass of the electron divided by 207 times the mass of electron plus 1836 times the mass of the electron. So if you calculate it, how much you will get? You will basically get 186.03 times the rest mass of electron. So this is the reduced mass of your system. That system was muonic hydrogen. In muonic hydrogen, you have proton inside nucleus and mu particle is orbiting around it. So there is no electron. Okay. So this is the reduced mass of this system. Okay. And you can think how much it is heavy as compared to hydrogen, right? For hydrogen, that reduced mass was just me. Incomparable. I mean, almost it is me. But for this system, that reduced mass is very high. It is 186 times the reduced mass of the electron. And it is obvious because both fellows has mass number is very high. For one, that muon particle, that is 207 times the mass of electron, and for proton, you know, 1836 times that mass of the electron. That's why that reduced mass is very high. Now you can proceed. How will calculate? So let us calculate the energy of nth level for this system, and then we'll use this formula we have derived, that is mu by me times the energy of hydrogen atom, right? So if you remember, last time we have derived this formula, and this is very important when we will go for any exam in future. Okay, in research also, this formula, the correction of energy, speed, and radius, this formula is very important. And I'm sure that you remember me that time. Okay, so please keep in mind, for any system that energy can be expressed in terms of the energy of hydrogen atom. Just you have to keep that reduced mass of that system. Now, can you please calculate that energy of nth level for this system? Anyone? So it will be basically how much? It will be 186.03 into mass of electron divided by mass of electron into the energy of nth level of hydrogen. That was nothing but 13.6 divided by n square, and unit obviously it will be in electron volt, and n is the principal quantum number. You people already know. Okay, can you proceed calculation? So what you have to calculate now, because that for Lyman alpha line and for Balmer alpha line, you have to calculate E dash 1, E dash 2, E dash 3 for calculation of first and second line of energy of first and second line of Lyman alpha line and first line of Balmer alpha line. That I'll proceed. Now can you please calculate that E on dash, how much it will be? Anyone? And please tell me, how much will be that E on dash?
Minus 2530.08.
2500. Can you please repeat?
2530.008.
Okay, very good, very good. So almost you are almost close. Very good. All others, are you calculating? Sorry. All others, please respond me so that I can proceed. So she is very close. Anyone? So I have calculated. You are close. That's not a problem. I have calculated it. I got around E on dash is minus 2529.6 electron volt. You can check also. Okay, every people are getting like this kind of number. Sorry, I didn't get. Can you, all are getting like this?
Get, sir.
Okay, very good. All others? Then you have to calculate E2 dash also. So E2 dash will be how much? E2 dash. E2 dash is how much? Please calculate it. So it's basically now it will be divided by how much? This number will be divided by how much? Anyone? Sorry,
By 4.
By 4. Can you please divide it and tell me?
Minus 632.5.
Very good. Minus 632.5, right? Almost. This number is, I mean, this is very close. I mean, that's not a problem. 2529 or 2530 also. Very close. That's not a problem. Ultimately, they will ask you that order. Okay. So this is around how much? 632.5 electron volt, right? What about E3 or E-3? What about this? Please tell me so that I can proceed. Now it will be divided by what? 9, right? Now it will be divided by 9, right?
281.06.
Okay, 281.06, or you can write 06 means close to 1, right? 28 on 1 electron volt. Okay, now for L alpha line, what you have to do for L alpha? Anyone? L alpha means first line of Lyman series. The energy delta E will be how much, or delta E1, let us say. That will be how much? E2 dash minus E1 dash, right? Because L alpha means what? That electron is coming from 2 to 1. That is L alpha. If it is coming from 3 to 1, that will be L beta, right? In first line, second line. Did you get what I'm saying? For L alpha, transition is happening from 2 to 1, or first line of Lyman series. Then that energy of emitted photon will be how much? Just the energy of this minus energy of this. So can you calculate it now? Every people agreed what I'm saying? Every people agreed what I'm saying, or any doubt in the class? Please respond me so that I can proceed. Is it okay, everyone? Anyone please respond me so that I can proceed. Sorry. Is it okay? Is it okay for all? Okay. Now please calculate it. So if you calculate it, you will basically get 1897.2 electron volt. So that is the energy of first line of Lyman series. So you will basically get approximately 1897 electron volt, 0.2, that's error also. Okay. What about that L beta or second line of Lyman series? How will do L beta? Anyone? So it will be energy difference between what state? Which state? Anyone? So L beta means photon is coming from 3 to on, right? I mean L beta is represent here the second line sorry, second line of Lyman series, right? So it will be basically E3 dash minus E1 dash. Okay? Is it okay? E3 dash minus E1 dash. If you do this calculation, E3 is this, E1 is this. So basically minus 281 plus 2529.6 in electron volt. In electron volt. If you do this calculation, you'll basically get 2248.5 electron volt. So L beta means E3 minus E1. E3 is how much? Just minus 281.1, and E1 is nothing but minus 2529.6. Just I have substituted these values and I got 2248.5 electron volt. What about first line of Balmer series? Anyone? What you have to do? Which difference you have to take? Which difference you have to take? For Balmer series, which difference you have to take? Okay. For Balmer first line, it is basically denoted as H alpha, and that energy delta E will be nothing but E3 dash minus E2 dash, right? And that is the actually first Balmer line. Because for Balmer line, that final state is always 2, and if initial state is 3, and that is making transition, that is the first Balmer line, that is alpha. So the energy of that emitted photon for Balmer alpha line will be just E3 dash minus E2 dash. If you do this calculation, how much you are getting? Approximately you will get. Please note that these are approximate number. Okay, 351.3 electron volt. Okay, 351.3 electron volt. Okay, every people got this?
Yes, sir.
Okay, shall I proceed? Now we'll do one beautiful problem. This is really beautiful problem. I hope next two problems people will enjoy. Okay, please write that problem. If hydrogen atom at rest, and it emits a photon in going from n equals to 5 to n equals to 1 state. Again I am repeating, if hydrogen atom at rest and it emits a photon in going from n equals to 5 to n equals to 1 state, find the recoil speed of hydrogen atom find the recoil speed of hydrogen atom in meter per second after this transition. So again, I'm repeating, if hydrogen atom at rest and it emits a photon in going from n equals to 5 state to n equals to 1 state, find the recoil speed of hydrogen atom in meter per second after transition. And also given that the mass of the hydrogen atom is, 1.67 into 10 to the power minus 27 kg. So I think you got this problem, right? Did you, every people understood this problem, or shall I repeat? Every people understood this problem? Every people understood?
Yes, sir.
Yes, sir.
Okay. So basically hydrogen atom, this is your hydrogen atom, it is at rest. Now what is happening? There is a transition from n equals to 5. Suppose let us assume this is n equals to 5. So there is a transition from n equals to 5 to n equals to 1. So there initially that hydrogen atom at rest, but after transition there will be emission of photon, right? So this photon will have some energy, and if photon has some energy, definitely there will be some associated momentum of that photon. So initially when it is at rest, it has zero momentum, but after making transition from n equals to 5 to n equals to 1, there will be emission of photon, and that photon will have some energy, or it will carry some energy. So there will be definitely some associated momentum of this photon. So due to this momentum conservation, there will be recoiling of this hydrogen atom in opposite direction of photon. So it will recoil in opposite direction, and that speed you have to calculate. Did you get, or shall I repeat? So initially hydrogen atom was at rest, so definitely there will be linear momentum will be 0. But it is making transition from n equals to 5 to n equals to 1. Definitely there will be emission of photon, and photon will have some energy, and of course there will be some associated momentum. So since this photon will have some momentum and it is in one direction, so there will be definitely hydrogen atom will be recoil in opposite direction to conserve this linear momentum. Did you got what I'm saying? Anyone? Please respond me. Did you get? Okay. So how will do this now? So from where to where the transition is happening? N equals to 5 to n equals to 1, right? So let us proceed for solution. So transition is happening from n equals to 5 to n equals to 1. And also the initial momentum will be pi. Let us assume initial momentum is pi, and that is nothing but 0 since hydrogen atom are at rest. So P equals to mv. V is the speed. Since it is at rest, V will be 0, and definitely that linear momentum is 0. And assume the final momentum is PF. Okay. So PF should be 0. PF should be 0 because linear momentum is always conserved. That's why it is called exact conservation laws. So since initially it is pi is 0, definitely that final momentum will be 0. But final momentum will have photon and also hydrogen atom, because when that photon will be emitted, suppose let us assume photon is emitting due to this transition in this direction. So hydrogen atom will move in this direction to preserve this momentum, right? So since momentum is a vector quantity, so this momentum should, if photon is emitting in this direction, that hydrogen atom definitely move in this direction to make it 0, right? But to calculate that photon momentum, you have to go to energy of this photon. How will you calculate that energy? How will you calculate this energy? Anyone in the class? Please respond me so that I can proceed. So energy will be how much? It's very easy. Just you have to calculate this, right? Energy of photon will be delta E, and that is nothing but h nu, and that will be energy difference between fifth state minus energy, energy of fifth state minus energy of ground state of hydrogen atom. Is not it? Is not it? So this will be the energy of that emitted photon. Okay. So if you calculate it, the fifth state means minus 13.6 divided by, not 13.6 divided by 5 square means 25. And that thing you know, that is nothing but 13.6 electron volt. Okay. So if you take 13.6 common here, you will basically get 13.6 into 1 minus 1 by 25 in electron volt. So that will be nothing but 13.6 into 24 by 25 in electron volt. Now how will proceed for SI calculation, in joule? How will convert it into joule? Anyone? So this energy, this is the energy of emitted photon. So this is actually in electron volt. To do it or to convert it into joule, what you have to do? 13.6 into 24 divided by 25. You have to multiply this number into 1.6 into 10 to the power minus 19. Now it will be in joule. So this is the energy of emitted photon. That energy is 13.6 into 24 by 25 into 1.6 into 10 to the power minus 19 joule. Did you people get? Now if you calculate it, you will get basically delta E, energy of photon, that is nothing but h nu. That will be 2.1 into 10 to the power minus 18 joule. 10 to the power minus 18 joule, okay, on 8 in joule unit, okay. Sekha, did you get? Dhruvi, did you get?
Yes, sir.
Anju?
Yes, sir.
Yes, sir.
Okay. Now can you proceed? This is the energy. Now how will you calculate the momentum of this photon? So this is the energy of this photon. Now I am asking how will you calculate the energy, momentum of this photon? So let us assume that momentum of the photon is P gamma. P gamma is the momentum of the photon. Momentum of emitted photon. Okay. So you know this formula, E square equals to P square C square plus M square C to the power 4, right? So where E is the energy, P is the momentum, M is the rest mass. But for photon, this mass is how much? For photon, it will be 0. So there is a relation between energy and momentum for photon, and this, if you make momentum is
Sir?
0, is not
Will
it?
this energy be kinetic?
Which one?
This energy.
Yeah, this energy is kinetic, you are asking. Yes, yes, yes. Actually, photon will have mass how much? Photon mass is how much? Yes, photon mass is how much? Photon mass is 0, right? Photon mass is 0, definitely you will have momentum. Is not it? I mean, if you see there is a relation for photon, I am giving your answer. E equals to how much? PC. You know, if E equals to PC, definitely photon will have kinetic energy, is not it? Did you get what I'm saying? Definitely that photon will have kinetic energy, because this is related to your what? Momentum. And if you know that momentum is related to kinetic energy of that particle, right? Kinetic energy is how much? How will define? P square by 2m, right? Yes. So
Yes, sir.
yes. So if you know that for photon that mass is 0 and E equals to Pc, so energy is directly proportional to P. So definitely that photon will have kinetic energy, right? Did you get answer?
Yes, sir.
Now can you calculate it? P equals to how much? Or basically I have denoted it as P gamma. So P gamma will be nothing but this energy. Okay. And that is nothing but E is nothing but here delta E, right? Delta E I have considered that energy. So here for energy you have to substitute this value and you have to divide this by C, and that will be your momentum of that photon, emitted photon. So basically it will be 2.1 into 10 to the power minus 18 divided by C. Okay, that will be the momentum of that emitted photon. Now what about that momentum of hydrogen atom? So let us assume the pH is the momentum of hydrogen atom, or basically H atom. Okay, H atom after transition. Okay. So E equals to Pc, you calculate it. Now can you, how will do this? So see, after transition, this is your momentum of hydrogen atom, and this is your momentum of photon, right? And this sum should be 0, right? Sum should be 0 because initially that system has 0 momentum. So after transition, the momentum should be 0. It means the momentum of hydrogen atom plus momentum of photon should be 0. And it should be in vector. What I'm saying, you have to make this 0 equals to P of H plus P of gamma. Because momentum is vector quantity, so you have to give this vector. And if you do it, you'll basically get P of H is nothing but minus P of gamma. So what is the meaning of minus here? Anyone in the class? What is the meaning of minus? What is the meaning of minus? Yes. Minus means if photon is moving on direction, there will be definitely in opposite direction we will have hydrogen atom. That is represent basically minus here. So minus is representing what? If the photon is emitting in forward direction, that hydrogen atom will move in backward direction. Okay, in opposite direction. That is the significance of minus here. Now that photon, if you take magnitude, because you have to calculate speed. Speed is a scalar quantity. So if you take magnitude, in magnitude, pH should be equals to P of gamma in magnitude. Okay, if you take mod. Okay, now pH is the momentum of hydrogen atom, so it should be the mass of hydrogen atom into its speed. Momentum of hydrogen atom is nothing but mass into speed, and that P gamma, you know, that is basically 2.1 into 10 to the power how much? 10 to the power minus 18, right? 18 divided by C. Okay. Now V is the speed of recoil speed of hydrogen atom, that will be 2.1 into 10 to the power minus 18 divided by that mass will be divided. Mass is how much? 1.67 into 10 to the power minus 27 into how much? 3 into 10 to the power 8, right? So I'm repeating this, that speed of electron will be how much? 2.1 into 10 to the power minus 18 divided by mass mass of hydrogen is 1.6 into 10 to the power minus 27 kg. Then you have speed of light c, that is 3 into 10 to the power 8. Okay. Now if you calculate it, you will get this number 4.19 meter per second. So that is recoil speed of hydrogen atom will be how much? 4.19 meter per second. Every people got it? Sekha, did you get?
Circuit.
Any problem? Dhruvi, did you get?
Yes, sir.
Anju?
Yes, sir.
Okay, any problem? No, right? Okay. So now we'll do one more problem. Shall I erase? Okay. Now another problem I'll do. Okay, I don't know whether I'll finish or not. I will able to finish or not. Let us proceed. Okay, let us write this problem. Please write this problem. A single electron orbit around a stationary nucleus of charge plus JD, where full stop, after that where Z is a constant and small e is the magnitude of electronic charge. A single electron orbit around a stationary nucleus of charge plus JD, where Z is a constant and E is the magnitude of electronic charge. Also, after full stop, please write it requires 47.2 electron volt to excite the electron from second Bohr orbit to third Bohr orbit. It requires 47.2 electron volt to excite the electron from second Bohr orbit to third Bohr orbit. Okay. Now write that question A, part A. Find the value of Z. That value you have to calculate. Find the value of Z. Okay. B, calculate the energy that is required to excite the electron from third Bohr orbit to fourth Bohr orbit. Okay. Part C, calculate the wavelength of electromagnetic radiation. That is required to remove the electron from first Bohr orbit to infinity. Calculate the wavelength of electromagnetic radiation that is required to remove the electron from first Bohr orbit to infinity. Part D, calculate the kinetic energy. Potential energy. Calculate the kinetic energy, potential energy, and orbital angular momentum of the electron in the first Bohr orbit. Calculate the kinetic energy, potential energy, and orbital angular momentum of the electron in first Bohr orbit. Last part, that is E, calculate the radius of first Bohr orbit. So really good question. You have many parts here. If you are able to solve this, many things will be cleared. So every people wrote this question. Shekhar, did you wrote? Okay, Dhruvir, any doubt?
Yes, sir. No,
Anju,
sir.
did you wrote this question?
No doubt, sir.
Any
Yes, sir.
doubt? No, right? Okay. How will proceed now? Let us proceed for solution. So how will do? So you know the for this system you have that charge at the nucleus is how much? Plus ZD, right? And on single electron is orbiting, right? So that energy will be, let us assume this is at nth state. So energy of this electron will be how much? Minus 13.6 into Z squared divided by N square, right? Did you get what I'm saying? Yes. Now what they said energy required, first you have to calculate that Z value, right? So they said that energy required to make transition from 3 to 2 or 2 to 3, that energy, excitation energy is how much? 47.2. I mean that electron is making transition from where to where? 2 to 3, right? And that energy is how much? That is needed 47.2 electron volt. So you have to calculate that separation between these two energy level, separation between these two energy, E2 and E3, and that is nothing but 47.2. So what you have to do? Delta E you have to calculate, and delta E is nothing but E3 minus E2, and that is nothing but 47.2 electron volt. Am I correct? Am I correct? Okay.
Yes, sir.
Now can you calculate it? E3 minus E2. So if you substitute here n equals to 3 and n equals to 2, you will get that difference. And if you calculate it, you will get, definitely you will get minus 13.6 into Z square divide so into 1 by 9 minus 1 by 4. And that is nothing but you have 47.2 electron volt. Is there any doubt? So minus, if you substitute it, first you will have which number? This number, right? Minus 13.6 into Z square divided by 9. Then you will have, you have to substitute n equals to 2, and that will give you 4. Minus 13.6 Z square I have taken common from this upper equation. So you will basically get minus 13.6 into Z square into 1 by 9 minus 1 by 4, and that is nothing but 47.2. Now in this equation only one unknown quantity is Z. So easily you can calculate it. If you calculate it, can you calculate it? Anju, can you calculate? Shekhar, Dhruvi?
Sir, 5.
Very good, very good. So it will be definitely 5. Very good. Very good. Now if you are able to calculate, now can you, everybody is getting this number? Everybody is getting this number? Please respond me. Everybody is getting? So Z, now you got this Z. Now you can easily calculate that energy required to excite the electron from 3 to 4. Is it? Is not it? So now second part, they said that energy required to excite the electron from 3rd to 4th. So how much energy will be needed? Now this state is 3rd and this state is 4th. Now known quantity is how much? Which is known? Z is known. So that energy will be how much? Delta E will be just E4 minus E3, right? E4 minus E3. So if you substitute this in this equation, basically how much you will get? Minus 13.6. So this is your basically B part I am doing. Minus 13.6. Now Z square will be 25, right? So E4 means 1 by 16 will come. Then you will have 1 by 9. Did you people get what I am saying?
Yes, sir.
So minus 13.6 into 25 into, if you take common, you will get inside bracket 1 by 16 minus 1 by 9. Okay. So can you calculate it? How much you are getting? Anyone?
16.52
Very good.
electron volt.
Very good. 16.52 electron volt. Very good. Very good. I hope you people are enjoying now class. So now this number will be, if you calculate it, you will get 16.52 electron volt. Okay. Now C part. Energy required to remove that electron from ground state to infinity, right? I will do this part. So that will be basically from ground to infinity, right? So C part I will do. Anyone? So now this state is, you are exciting electron from n equals to 1 to n equals to infinity, right? So that energy will be how much? Delta E. And that will be nothing but E infinity minus E1. Is not it? Is not it? Any doubt? Am I writing correct? This is correct, right? So energy required to excite, energy of EM radiation that is required to excite the electron from first to infinity state. And that will be how much? E infinity minus E1. So E infinity will be how much? 0, right? Because 1 by n square, and n value is how much? Infinity here. So 1 by infinity square will give you 0. So definitely that is nothing but minus E1. And E1 will be how much? Minus E1 will be how much? 13.6 into 25, right? 13.6 into 25 in electron volt, right? Did you people get what I'm saying? Or shall I repeat?
Yes, sir.
So how much it is?
340.
340, right? Very good. So this will be 340. Very good. Now, D part, that kinetic energy, potential energy, or angular momentum in the first Bohr orbit. So how much it will be? Kinetic energy will be how much? D part. So you know that ground state energy, that is how much? Just you have calculated that ground state energy E1, right? So E1 is nothing but D part. This is your D part. So E1, if you have calculated, that is nothing but minus 340 electron volt. Just minus 13.6 into 25. That will provide you the ground state energy. And if you remember, I have derived that kinetic energy of any state is nothing but that energy minus of total energy of that state. Did you remember? Anyone? Anju, do you remember this formula? That kinetic energy of any state is nothing but minus of total energy. You know that total energy is how much in ground state? That is minus 340 electron volt. So kinetic energy of ground state will definitely be 340 electron volt. Is not it? Kinetic energy will be how much? 340 electron volt. Did you get? Okay. Or any doubt in the class? What about potential energy of ground state? Potential energy will be how much? So if you remember again this formula, potential energy is nothing but of any state is nothing but minus twice of kinetic energy of that state. Do you remember this formula? Okay. Now if you do substitute this kinetic energy, definitely will get minus 680 electron volt, right? Okay. Now
So
how?
C part it is plus 340, right?
Huh? Kinetic energy. Kinetic
C
energy.
part.
C part, yes, plus 340, yes. That energy 340. Every people are getting right. 340 plus 340. Because E1 minus, I have done like this, na.
So you have written minus 340.
Oh, sorry. For this is typos, nothing, right? So E1, actually this is E infinity minus E1. So E infinity is 0, and you have minus E1, right? And minus E1 is nothing but minus 13.6 into 25. So this minus will make you a plus, and this number will provide you 340 electron volt. Sorry for typos if I made mistake. Okay, please correct it. Extremely sorry for this typos. Okay. So
Sir,
you
the D
calculate.
part.
You calculated now kinetic energy is 340 electron volt. Potential energy of that state or ground state will be minus 680 electron volt. Now what about angular momentum or orbital angular momentum? I have asked orbital angular momentum also, right? That will be how much? So if you remember, I wrote that first days that angular momentum is how much? L for nth state was how much? nh cut. Do you remember this formula? First days I derived, right? That orbital angular momentum is quantized for orbital electron, and that can take value h cat, 2h cat, 3h cat, like that. So it is discrete. Now can you please tell me that ground state orbital angular momentum will be how much? It will be simply n equals to 1, definitely it will be simply h cat. So very simple, right? But it makes confused, right? Please reply me so that I can proceed. Did you get this? So for ground state, that orbital angular momentum will be how much? Simply h cut or reduced Planck constant. What about that Bohr radius? Anyone? Last part? So Bohr radius will be how much? Simply, if you remember this formula, Rn was how much?
Square A0.
Hmm?
N
So
square A0.
very good. N square A not 0, right? Divide by Z. Did you forget this Z? Because now the system is not simple hydrogen, right? It is hydrogen-like atom. So if you remember, for hydrogen-like atom, you have Z factor also. Is not it?
Yes, sir.
Now for ground state, N will be 1. So it will be R1 is nothing but A naught by Z. Okay. A naught was how much? 0.53 angstrom. If you make it in meter, you will get 5.3 into 10 to the power minus 11 meter. Divide by Z is how much? 5. Is not it? So basically you will get 1.06 into 10 to the power minus 11 meter. 1.06 into 10 to the power minus 11 meter. That will be the radius of first Bohr orbit for this system. Did you people get? Did you people get?
So Z value 5 to I take guess.
In first part you have calculated that Z value, right? First part you have calculated Z equals
Okay,
5.
okay.
Yes.
Okay.
Okay. Now if you have completed, I should stop. Every people completed?
Sir.
Okay. Shall I stop? Okay. Okay, then I am leaving. Okay.
Sir.
Bye all.